Alrighty, so we're going to do, this is worksheet types of energy and their equations part 3, and we're going to do problem number 2 with the skateboarder. So the first thing that I want to notice is what type of energy I have at each of these places. So up at the top, my velocity is 0. Here, I do have velocity. I don't know what it is though. At the velocity at the bottom, I don't know what that is. And then here, I don't know what this velocity is either. But the main thing is that I know that it does have velocity. So the next thing I'm going to do is look at gravitational potential energy. Here, I will have gravitational potential energy because I have height. So in terms of my pie charts, my kinetic energy is 0 because my velocity is 0. So the only type of energy I have left then is gravitational potential energy. On the way down, it has height, so it does have gravitational potential energy, and it is moving. So that means I have both. I'm just going to do a small bit here because he hasn't gone down very far. So he mustn't have too much kinetic energy yet. He's going to be going slowly. But he has a lot of gravitational potential energy. He's still up pretty high. This one here, his height is 0. When your height is 0, you do not have any gravitational potential energy. So that means all of this must be kinetic. And then here, he is moving and he has height. Therefore, he has both gravitational and kinetic. And this one, I'm going to have more kinetic because he's down lower, and then some amount of gravitational potential energy. Now, how you divide this up, I don't really care, just as long as this GPE here should be more than the gravitational potential energy at the end, because he's lower there than he was at the other spot. So as long as the fourth gravitational potential energy is smaller than the second one, you're good. All right, so now I'm going to use this to plug in numbers that I know just from looking at my pie charts. So at the top, at the highest place, I have actually all of these heights because they're on these little measuring tapes. So that's 7.45. This is 5.64, 0, and 3.74. Okay. At the top, he was not moving. Therefore, my kinetic energy will be 0. At this one here, the height is 0. Therefore, my gravitational potential energy is 0. And I think that's almost everything. The only other thing to note, I'm going to make this line a little thicker between the energies and the other stuff, is that there's no springs. So we don't have any energy stored in the springs. So all of these spring potential energies will be 0. All right, so the only thing we have to do next then is to use our equations, and I'm going to write those in. And we're going to solve for these energies and then fill in our total energy. So gravitational potential energy is equal to mgh, where m is mass, g is 9.8, and height is how high you are. So the mass of this thing, it says, was 105 kilograms. So to figure this out, we're going to go 105 times, so that's just the mass. G is always going to be 9.8 on Earth. And then my height was given to you over here, so that is 7.45. Throw that in a calculator, and I get 7,666.05. If you leave off the 0.05, that's fine. For the next one, I'm going to just do the exact same thing, but now I'm going to do it with a different height. So my mass is the same. It's still 105. 9.8 is still G. That hasn't changed. It's still on Earth. And now I just need to multiply by 5.64 instead. And I get 5,803.56. And then we're going to do the bottom one the same way. Perfect. All right, so we've put in our zeros, and then the next step was that we put in the gravitational potential energies that we can solve for. The next thing that we need to do is figure out total energy. And all we need is a row where we have all of the energies. So I'm going to look right here, and I notice, look at that. I have 3 energies here. So if I add them up, I can get my total. So I'm going to use these 3 and just add them up, and I get 7,666. And then energy has to stay the same. Energy cannot be created or destroyed. So then that means the rest of these are also going to be 7,666. Once you do that, you kind of work your way backwards to the left, because I know still these need to add up to be 7,666. So for this row here, I can go, okay, so it has to add up to 7,666. So 5,803.56 plus whatever this is going to be, I'll call it X, is equal to 7,666. So that means I'm going to subtract it from both sides. And what I get is going to be 1,862.44. Excellent. I'm just going to leave off this 0.44. It's fine. 1,862 is good enough. All right. And then this one is going to be 7,666 because these have to add together. And that's the only way that's going to work. And lastly, I'm going to do the same thing here. So 7,666.05. And I'll just subtract from it the 3,848.46. And I get an answer of 3,817.59. All right. Now that I have that, I have all of the energies filled in, which means now I can find my velocities. And finding my velocity is going to be the same thing as I did before, where I can solve for my velocity using the kinetic energy equation. So if I look at all these equations, the only one that has velocity in it is kinetic energy. So that's how I know I need to use that equation. So I'm going to use kinetic energy is equal to 1/2 times my mass times the velocity squared. The kinetic energy, let's start with this one here, is 1,862. That'll be equal to 1/2 times my mass, which is 105, times v squared. We'll zoom in on this. All right. Most students make the fewest math mistakes if they multiply this out first. So 105 divided by 2 or times 0.5 is 52.5. And then the opposite of multiplication is division. So because this is multiplication, I need to divide by 52.5. Do not subtract. Do not subtract. Okay, so 186.2 divided by 52.5. And I get 1,000. Oops, I started rewriting what I was typing into my calculator. And I get 35.466666. And we can just round that up to 35.5 as v squared if we wanted to. Actually, we're going to leave it like this. Okay. Equals v squared. The opposite of square is square root, so we're going to square root both sides. And I get a velocity of 5.955. which will be my velocity. And if you want to round up and you want to say 5.96, that's fine. All right, and that's it. So then all you need to do is do the same thing over and over again. So this becomes 5.96. And then I could do the same thing for the other ones. So my kinetic energy is equal to 1/2 times mass times velocity squared. Plug in the numbers. Multiply it out. Divide by 52.5 because it's multiplied. And I get 146.02 is v squared. The opposite of square is square root. And I get 12.08. Plug that in here. Last but not least, do it again for this one. This time I'm using this kinetic energy. Multiply the 1/2 times the 105. Divide by 52.5. I get 72.716 is equal to v squared. Opposite of square is square root. And I get 8.53 is equal to my velocity. And there we are.